with the cortical regions that influence movement. Just a little bit of a review. What's this lobe over here called? Frontal. Okay. This lobe here, what's that? That's temporal. Okay, what's this down here? Cerebellum. Good. So cerebellum, balance, coordination, all that stuff. Okay, this lobe back here, occipital. Okay, and then there's our old friend here, right down the middle. What's that called? Anybody? Anybody? Yeah, that's your central sulcus. All right, and then that makes this back here. What lobe is this here? Parietal. Perfect. Okay, what influences movement? There's a couple of things we need to talk about. First is here, right in front of the central sulcus. What did we say was there? Great, that's your precentral gyrus. Okay, that's also known as your primary motor cortex. Okay, so your precentral gyrus, that's the little bump that's there. It's also called your primary motor cortex. Okay. In addition to the words precentral gyrus, primary motor cortex, you may in the future see it also referred to as M1. And M1 just stands for primary motor cortex. Okay, that's where all the neuronal cell bodies that are going to be responsible for voluntary movement reside. Everything comes out at M1. Okay, really important motor cortex to know if you're going to be a PT. That resides in your frontal lobe. Okay, behind the central sulcus is going to be this thing that we've talked about before. What's behind the central sulcus? That's going to be your post-central gyrus. Okay, your post-central gyrus is also known as your somatosensory cortex. Okay, your somatosensory cortex. It's right behind your central sulcus. And you may, in the future, or may hear another term for somatosensory cortex. So this is your primary motor cortex. Your somatosensory cortex is going to be S for somatosensory 1. Maybe got color to it. Where's my room? Okay, so just in front and a little bit on the bottom, in the area of my primary motor cortex, there's a new area I'm seeing for the very first time today. And this is known as your premotor cortex. Your premotor cortex is abbreviated PMC. And that's all going to be related to motor function. It's going to be really important for motor planning purposes. See that here in a minute. Just above your premotor cortex, but still in front of your M1 region, is going to be your supplementary motor area. And that's abbreviated SMA. Okay, so 2 regions, really important for motor planning. Everything has to go through your premotor cortex or your supplementary motor area before M1 is going to fire, cause voluntary movement. Okay, they're involved in motor planning. We're going to talk about that as we go. And looking on down, there's something else that's going to be really important here in motor control, and that's this thing that we've drawn before and labeled. What's that? That's your thalamus. Okay. Okay, your thalamus is going to be really important for receiving all somatosensory information, or all sensory, even not somatosensory. All information goes through the thalamus. The only sensory information that does not go through the thalamus is olfaction. Okay, everything else goes through the thalamus. So thalamus is going to be really important, and it's going to convey information all the way up to both your premotor cortex and your supplementary motor area. Okay, so all information about senses coming in through the system are going to be relayed through the thalamus, and the thalamus is going to communicate directly with your premotor cortex and your supplementary motor area. There's also another main player that we've looked at a little bit but haven't really drawn yet, and for the purpose of today's talk, I'm going to choose to represent them in a purple color. Okay. They're a group of structures. They're actually a group of neuronal cell bodies that reside in the area of the thalamus and the lateral ventricles, and these as a group are known as the basal ganglia. Does anybody know a disease process that's associated with problems in the basal ganglia? Any thoughts? Ever heard anything before? Parkinson's, great. Parkinson's disease is associated with problems with changes in the basal ganglia. Another common problem, or not common unfortunately, but it's an inherited disorder, is Huntington's disease. Okay, so basal ganglia, important. And what happens with the basal ganglia is it also is going to be involved in relaying information to the premotor cortex as well as the supplementary motor area. Okay, basal ganglia are really important for initiation of movement and basic amplitude of movement, like whether the excursion is really large or really small. When we get to the basal ganglia part of the course, we'll talk more about that. Okay, really important for motor control. Now, if you had to pick another structure on this picture that's going to be involved in motor control, any thoughts about what it might be? Cerebellum. Cerebellum, perfect. Yeah. So cerebellum's also going to be involved in providing information to the premotor cortex as well as the supplementary motor area here. Okay, cerebellum's going to be involved in conveying information about what we talked about before was non-conscious or unconscious proprioception. That means, without looking, I know where the position of my joints are in three-dimensional space. Okay, it's a little bit different. I know, my brain knows because my cerebellum is conveying that information to my brain. I know if I close my eyes, I know where I am as far as my body is concerned. Okay, that's why that's important. Okay. So if I want to start a motion, I need to know if my hand's going to be on top of my head or is my hand in my pocket. Right? Makes a difference as far as what I want to do with the motion. Okay, and there's one more. Choose this one. one more thing that we're going to talk about, and that's going to be right here. It's in the parietal lobe. It's just behind the somatosensory cortex. Okay, and this is called your posterior parietal cortex. So posterior parietal cortex. It's an abbreviated PPC. Okay, it's the job of your posterior parietal cortex to take information coming from the occipital lobe. And what is the occipital lobe used for mostly? Does anybody remember? Vision. Great. So it's going to take visual information coming from the occipital lobe, and it's going to coordinate that with somatosensory information coming from the somatosensory cortex, or S1. Let's make that blue. Information coming from somatosensory, information coming about vision is going to come together and be interpreted in the posterior parietal cortex. And then that information is also conveyed to my supplementary motor area and my premotor cortex. Okay, that's all going to be important for motor planning. Now, the posterior parietal cortex, really important to convey information about vision. So if I'm just walking on a trail somewhere, lots of trails outside, you can go out in the woods and just walking along, and my intention, my M1's firing for walking, I'm walking along, and then all of a sudden I see a snake. I need to be able to say, I gotta stop walking, right? So that's where that comes in. That information is like, whoops, I gotta stop. Even though I was thinking about walking, my motor plan has to change from walking to, I don't want to step on the snake. Kind of thing. That's why that's important. So it's conveying information from somatosensory cortex. Information coming in from somatosensory cortex could be I might be cooking something in the kitchen, and I'm in a rush and I forget to grab a pot holder, so I just grab the pot to empty it out, and then I just stop my motor plan in mid-track, right? Because it's hot. It's going to hurt. Don't want to do that, right? So that's why those things are all important for my motor planning. And then it's going to be the job of the supplementary motor area and the premotor cortex to convey information to my primary motor cortex. To say it's okay, keep going, everything's good, or we need to stop and do something different. Okay, so essentially, information coming from the thalamus, from your basal ganglia, your cerebellum, all those areas are conveying information into your supplementary motor area, premotor cortex, as well as your somatosensory region, and vision information is being processed in the posterior parietal cortex. That information comes in here. This is all involved in motor planning. You're going to have an entire course next semester with Dr. Raddick on motor control, motor learning. Okay, and he's going to talk a whole lot more about that. Questions? That makes sense? This is all what's involved in voluntary movement. We have a choice of whether or not we're moving. Lots of information, lots of things coming together to make that happen. Okay, let's go ahead and move on to the next is going to be the descending motor tracts. This is just a little bit of a review. We've kind of covered all this stuff when we talked about the overview of the spinal cord, but we're going to talk about these in a whole lot more detail today. Okay. So one thing I'd like to do is let's go ahead and divide it left and right. That way we can see when things cross over. Or I think it's easier to see when things cross over if we put a line right down the middle. This is something we talked about. So up here in your M1 region or your primary motor cortex is neuronal cell body. Okay, that's going to be your neuronal cell body of your upper motor neuron. UMN is upper motor neuron, and that's a cell body. Okay, upper motor neuron, cell body sends out axons that descend through the cortical region, ipsilaterally, through the midbrain, through the pons, and then at the level of the caudal medulla, this axon is going to decussate, goes contralaterally, heads on down to the appropriate spinal level, and then is going to synapse with the lower motor neuron. And the lower motor neuron here, we talked before about it residing in the ventral great horn. Okay, lower motor neuron comes out and is involved in innervating skeletal muscles. So this is voluntary movement. Said a few things. So this is your upper motor neuron, way up here. Way down here, you have this is your lower motor neuron. Okay, two different words. We'll talk more about those later on today. Does anyone know the name of this tract as it comes down? This one right here that's coming out of the upper motor neuron. What's the name of that tract? Yeah, that's your corticospinal tract. Good. It's because it goes from the cortex to the spine. So corticospinal tract. And your corticospinal tract has another name as well. I think somebody asked me before if it was the same as something else. Has anybody heard of that? Okay. It's also called, it's also known as pyramidal tract, like a pyramid. It's pyramidal tract. So pyramidal tract and corticospinal tract are really two words for the same thing. Pyramidal, like pyramid, Pyramidal tract. Okay, so when I say corticospinal tract or pyramidal tract, more often than not I'll say corticospinal tract. But if you hear pyramidal tract, that means the same thing. Okay, so this is the tract that's carrying motor information down to the rest of your body. Missing a color. Okay. Previously, we also talked about, so going down, this is the only one that's under voluntary control. Okay, we choose to move through this tract. There's also another motor tract that's descending as well, and there's a nucleus that resides in the midbrain. Does anybody remember the name of the nucleus that resides in the midbrain that's responsible for? Yeah, there you go. That's the red nucleus. Okay. Similar to the corticospinal tract, the red nucleus, from the red nucleus, axons coming out immediately decussate to the opposite side, and then head on down, straight down through the pons, through the midbrain, and they're going to synapse with a lower motor neuron. Here, and that lower motor neuron is going to come out. And in humans, it's specific for upper extremity flexion, mostly elbow flexion in humans. Okay, so this one is not under voluntary control. This is just automatically going all the time. Okay, it's the job of the corticospinal tract to put some influence on this particular tract, and this tract is known as the rubrospinal tract. So rubro from the red nucleus to the spine.
What is the center of
Elbow. Mostly in humans, it's elbow flexion.
So this is involuntary?
This is involuntary, yeah, it's always there. We don't have any control over the descending motor commands put out by the red nucleus or any of the others that are residing low. And another way to remember that it's involuntary is it's below the level of the cortex. I mean, all your reasoning and planning and thought happens up here. So it starts in the midbrain. So it's real low level. There's no conscious thought there to help control it. Conscious thought's controlling the corticospinal tract. Yes? Yes, corticospinal tract is the only one under voluntary control. That means my brain is involved in, or my cortex is involved in controlling it, as well as, my premotor cortex, the supplementary motor area, basal ganglia, thalamus, all that input is coming there to control my movements consciously. Do you have a question, Pat, or just stretching? Just stretching. Okay, that's fine. Any other questions? Yeah.
What did you say was regulating that? That was inhibiting that?
So it's not. So the corticospinal tract. Yeah, the corticospinal tract essentially is involved in controlling it, keeping it under control. Okay, and that's more advanced. But the corticospinal. Once if something, the upper motor neuron here is damaged, then you get hypertonicity or something different, all because it's not working to control the flexion anymore. Any other questions? Okay, and then there was others that we talked about previously. Here, the level of the caudal pons. There's another nucleus that we talked about. Yep, that's my vestibular nucleus. Okay, and with vestibular nucleus, axons coming out of here are going to come straight down through the medulla, stay ipsilaterally, and they're going to synapse on lower motor neuron cell body. It sends out axons. Does anybody remember what kind of musculature the vestibular spinal tract? Yeah, that's your extensor musculature. So, extensors. Think postural extensors, because when you're upright against gravity, you want your postural extensors to fire. Okay, and then this orange. So going from the vestibular nucleus to the spinal cord, this is your vestibulospinal tract. Do you have a question, Sophie? You look like you're just looking. Yeah.
No, I'm good.
Are you sure? Something I wrote?
No, I spelled something wrong.
Oh, that's okay. Yeah, I probably did too. Okay, now there's one more thing that we need to consider. The last thing we need to consider here as far as put it in a different color. Something having influence on some kind of motor tract that's coming down. And here in the medulla, the area of the medulla, there's a diffuse set of nuclei that together are involved in awakeness or awareness. Does anybody remember what those are? Yeah, it's your reticular formation. Good. Reticular formation. Okay. And your reticular formation, these nuclei reside in the medulla. Axons coming out, these neuronal cell bodies are going to stay ipsilateral, come down and synapse on a lower motor neuron cell body. That lower motor neuron cell body is responsible for, does anybody remember what kind of musculature it innervates? Extensors, yeah. So you get up out of bed, you extend, right? You want to come up. So extensor. So being awake and aware is associated with extensor muscles. And that's it. Coming down, we have the corticospinal tract. Corticospinal tract under voluntary control comes all the way down at the level of the caudal medulla, crosses over, decussates, synapses on our lower motor neuron cell body. Red nucleus decussates immediately, comes back down. Red nucleus, cerebrospinal tract, responsible for upper extremity flexion, mostly elbow flexion. Vestibular nucleus, axons coming down, hits extensor musculature, and from reticular formation coming down, also hits extensor musculature, and I didn't label this. This is your reticulospinal tract. Questions? Yes, Jane.
For the reticulospinal tract, is that also postural extensor muscles, or is that?
Yeah, mostly postural extensors. So postural extensors in humans, so in animals, if you're on all fours, you'd also be getting the biceps things. As long as you associate extensor musculature, so think lumbar, thoracic, quads, all the things that you need to stay upright. Yes. No, all activated. Yes. Anything. The only one that's voluntary is your corticospinal tract. Everything else is involuntary. And why that's important? Okay, Bobby, did you have another question?
Which ones are the extensors? Is the one that fires when you're in
Okay. So there's two. Probably a good way. So Sophie was asking which one was voluntary. And, the only one that's voluntary is going to be anything that's in the cortical region. Okay? Let's say that's damaged. What do you have left firing? You have your cerebrospinal tract, you have your vestibular spinal tract, and your reticulospinal tract, right? So those are the things that are left. So most common presentation for upper extremity after a stroke when you've damaged that is going to be flexion. That's due to the predominance, nothing's controlled in that cerebrospinal tract. Most common presentation for hypertonicity in the lower extremity is going to be extension. That's due to the influence of the vestibulospinal tract, okay, and your reticulospinal tract. Okay. Now, there's two different presentations in a coma, which is, I think, your question. Okay. Now, if you have a lesion that is, let's see, above the red nucleus, how do you think your patient's going to present? Section up here, but extension down below, right? Now, how about if you you have a lesion below the level of the red nucleus? How's your patient going to present? Extension everywhere. Yeah, actually, it's wrist flexion. That's one of the weird things. But elbow extension and lower extremity extension as well. Two different presentations. Decorticate rigidity, elbow flexion. Decerebrate rigidity, extension pretty much everywhere. Does that answer your question? Okay. Two different things that you're going to see next year when we talk about coma. Other questions? Does that make sense, Ed? Yes? Yeah, it's more important. She asked me a question, so I can answer it, but it's more, and you probably won't see it this year. Other questions? You might see it in CP3. I don't know what they're going to see. Yeah. Everybody got that? Does everybody see where we are? Okay. Let's go ahead and take a 10-minute break.